Serverless functions offer the industry's best code-to-cloud experience that's available today. There's no upfront investment to speak of, and you can get started so quickly, and there's little to no operational overhead. They do, however, require some special considerations in development, particularly with regard to handling persistent state. Functions are stateless by design. Their lifecycle is managed by a cloud platform, and they just wink in and out of existence, right? It's very common for functions to experience spiky usage where traffic volumes are shifting reliably and unpredictably. However, a lot of relational databases and other sort of instance-based or long-lived, kind of non-auto-scaling databases are connection-oriented. Meaning what? Meaning they're designed to work with a limited number of long-lived clients, like web servers. By contrast, functions as a service or cloud functions are ephemeral and very short-lived, meaning that their database connections are numerous and very brief. If the function tier scales up to hundreds or even thousands of requests, the downstream relational databases are just going to get completely overwhelmed with connection requests. Similarly, scaling down, even from reasonable heights, can leave resources already allocated and stale connections. That would deny subsequent requests from the function tier because the system is busy trying to figure out how to reclaim those resources, if it gets reclaimed at all. Now, sure, of course, do these databases have some sort of scaling capabilities? Of course they do. But often, even with some teams implementing do-it-yourself auto-scaling, you are using things like Terraform, Ansible, Puppet, Chef. These are essentially outside-in approaches where you're basing it off a trailing indicator of load. You're only scaling once CPU, memory, network, disk are getting near to exhaustion. And, who wants to chase down shards and out-of-sync replicas? I mean, that's an out-of-operations nightmare, especially when customers-facing data could be at stake. Now, a cloud-native or a serverless database should be able to observe the internal state of the database and base its scaling decisions off of that, and of request volumes to enable better and more efficient scaling. Now, auto-scaling databases that can scale that intelligently should be able to analyze things in real time as well as look at historical data so that you're reacting to issues immediately and predicting future traffic patterns. Now, sure, scaling down, of course, is just as important as scaling up. Maybe even it's more important, actually, because it's the key to lower operating costs. So databases that just can't auto-scale down, they'll never be able to compete because you're paying for that idle time. Even when you employ workarounds like connection pooling, connections are left open by design, right? So you're continuing to consume resources. You're just never going to be as resource efficient as your serverless auto-scaling counterparts. Now, traditionally, the sort of app to database connection is made using drivers or native clients. And then more modern databases have taken to exposing their data access layers in standards-based APIs. Now, exposing your database as this kind of an API really reduces the learning curve for the developer. And the more fluent the API, the less that how the database represents the world is going to kind of leak into your function code, making it easier to read and write and debug. Of course, test suite and release automation are also pretty important these days in modern application development. So having an operational API is really important for CI/CD pipeline integration. Now with AstraDB, the data API gateway implementation is an open source project called Stargate. And it does more than just automatically configure these data access layers via APIs for each of your database instances. It also further decomposes the monolithic system in AstraDB so that it's a microservices architecture. It separates query coordination from storage, right? So as different nodes in the Cassandra cluster. So your scalability isn't all or nothing, and that flexibility to scale, compute, or query coordination from, an I/O intensive workload like storage means you can place it on hardware that's optimal for that task, improving your cost efficiency. Now, function to database connections with the traditional drivers can sometimes be tricky with serverless functions because often, the traditional native drivers were usually designed to expect a long-lived server instance, right? Hard-coded IP, where's my virtual instance? Maybe even a file system that it expects to be around for more than a few hundred milliseconds. These are just not things that serverless functions truly provide. So Yes, of course. Workarounds here are certainly possible, and with modern drivers like the ones that are available from DataStax, they can certainly be cloud aware. But having both options can be pretty important, as you'll see in just a moment. Now, coming back to exposing databases as APIs, it can neatly sidestep, potentially having to do workarounds to accommodate binary native driver connections, because the database's API keys can just get stored in a credential manager or a secret manager, like AWS Secret Manager or Azure Key Store or Google Secret Manager. Now, the Stargate open source project allows AstraDB to function also as a schemaless JSON document database. So you can handle, your function tier can handle structured as well as unstructured data, and it basically makes AstraDB a truly multi-model NoSQL database. Now, the flexibility in having different kind of connection strategies is pretty important because, sure, lots of applications are designed for scale with, from the outset and have no tolerance for future rewrites or redesigns. But of course, it can make sense, and often does, to prioritize, ease of development and faster routes to market, because you've got to ship features early on, knowing that you have a future redesign or rewrite ahead of you. So being able to have strategies at different points along the spectrum is pretty important. REST, JSON, great for early stages of the application lifecycle when you're just trying to ship functionality, and then, hey, maybe your application load and your adoption from the users is increasing. That's where, you're going to decompose into microservices. Great, gRPC and GraphQL can be very handy in those instances. And then for apps that are designed for global scale right from the outset, or maybe the ones that have evolved to that point naturally over time, native drivers offer the best possible performance. And if you want to expand into a new region, pairing serverless functions with a serverless database like AstraDB can drastically reduce costs when you're scaling both horizontally and vertically in a new region. In the example there on the left, we have a single logical global database that's spread across 3 data centers, right, in different regions of the world. So if you were to write some data in an Americas data center, that change gets automatically replicated at the speed of wire over to the data centers in Europe and APAC. Now, DataStax is also working on intercloud for AstraDB, which is aimed at users that have these kind of multi-region deployments, but they want to use more than one cloud provider. Today, you can only replicate data within a single cloud provider, but soon AstraDB will support replication across cloud providers and between cloud providers. This would be a huge win for function developers, because then they can use any of the function providers' programming models that you want, and yet things are still resolving to the same data and database. So why not give it a try right now? Our free plan is really generous, and there's no credit card required. You can just sign up in a click or two with Google or GitHub and that sort of thing. So try it out and let us know how we can help you. We look forward to helping you succeed with Apache Cassandra and AstraDB.